Elementary Algebra, Final Assessment 2, Review, questions 4 through 6. In question number 4, you see a set of parentheses on both sides. So we're going to simplify the equation by first clearing the parentheses. Second, we'll look for like terms to combine. So let's start by distributing the 2 through the parentheses. So a 2 times a 2z creates a 4z. A 2 times a negative 3 creates a negative 6. Next, we'll distribute this 3 through the parentheses. This creates a 3 times z, or 3z. Then 3 times 5 to make a positive 15. And finally, just bring down the z. Next, we'll combine like terms. The left side, there are no like terms. On the right side, we see the 3z and the z. These are like terms. So we'll combine the 3z plus the 1z to make a 4z. On the other side, copy down as is. All right, next we want to look at moving our constants with our variables. I have a 4z and a 4z. It doesn't matter which way I move this problem. I'm going to run into a situation where my term with the variable is going to completely cancel. Let's look at it this way. If I subtract the 4z off of the right side, then I have to subtract the 4z off the left as well. So when I look back here, I end up with a negative 6 equals a positive 15. When we think about that, a negative 6 and a equal to 15, this is not a true statement. This is what we view as a contradiction. This is an equation that has no real number solution. So when we look at this problem, we'll say it has no solution. Now we want to look at problem 5. We want the r on its own, so we're going to move the 6 to the other side using the addition principle. So we're going to subtract a 6 off both sides. This leaves us with a 7r plus 0 equals 63. So in this problem, we have 7r equals 63. This problem is slightly different from questions 1 through 4. We were using in questions 1 through 4 only the addition principle. In this one, we see we have a 7 multiplying to the variable r. So we're going to need to use the multiplication principle of equality to solve this problem. To use the multiplication principle of equality to eliminate a coefficient in an equation, multiply both sides of the equation by the multiplicative inverse of that coefficient, or divide both sides by the coefficient. In this case, what we're looking at is a 7 that is multiplying to the r, so we are going to divide this coefficient 7 to both sides to clear it. A 7 divided by a 7 leaves a 1, so we're left with 1r, or r, on the left side. Then we want to divide the 7 into the 63. 7 goes into 63 9 times. So we're left with r equals 9. If we wanted to check this problem, we can take the r, which is equal to 9, and plug it back into the original equation and solve as a check. In problem number 6, we have 7/8 times x. Oops, there's an error here. Let's correct it. Okay, this looks better. We have a 7/8 times x equals a 63. We're going to use the multiplication principle of equality again but this time we're going to eliminate the coefficient 7/8 by multiplying both sides by its multiplicative inverse, which will be an 8/7. So I'm multiplying by 8/7 on both sides of the equation. This clears the 7/8 off the left side, leaving only x. On the other side, we're left with a 63, which I can put into fraction form by putting over a 1, multiplied to an 8/7. I can multiply these straight across and then reduce, but I can also reduce before multiplying by looking across for anything that will divide into a value from the top as well as a value from the bottom. When I look at the 1 to the 8, there's no reducing a 1. It's as reduced as it will get. However, the 63 to the 7, I know that 7 will go into 63. So I'm going to divide 7 into the bottom here to get a 1. I'm going to divide the 7 into 63 to get 9. Now when I multiply across, I have x equals a 9 times the 8 from the top to create a 72, and a 1 times a 1 from the bottom to create a 1. In simplified form, 1 goes into 72 times. So the answer is 72.